before galaxies, before stars, before atoms, before light itself existed. The universe was a place governed entirely by physics, so extreme that our current understanding collapses. To uncover the origin of everything: space, time, matter, energy, and the laws that rule them, we must journey back 13.8 billion years, back to when the universe was smaller than a subatomic particle, hotter than the core of a supernova, and more dense than anything we can imagine. This is the story of the birth of the universe, told through the lens of modern physics. In cosmology, the universe means far more than stars and galaxies. It includes all space, all time, all matter and energy, quantum fields that fill the vacuum, the physical laws themselves according to general relativity. Space and time are not a backdrop. They are dynamic, stretching and bending depending on mass and energy. So, when we talk about the beginning, we don't mean something exploding into space. We mean space itself coming into existence. There was no before in the classical sense, because time emerged with the Big Bang. The Planck Era is the earliest moment we can even attempt to describe with physics. Time, 10 seconds after T equals 0 temperature, 10 Kelvin energy density, 10 grams cmy at T. This scale, quantum mechanics and general relativity must both operate. Gravity is not weak, but as strong as the other fundamental forces. Space fluctuates violently. The universe is smaller than the Planck. Length, 1.6 times 10 meters. Space itself is a frothing quantum foam, where virtual particles appear and disappear faster than light can travel the diameter of a proton. Because we lack a complete quantum theory of gravity, we cannot fully describe this era. Several models attempt to string theory suggests the universe was dominated by vibrating strings of energy. Loop quantum gravity suggests space was discrete and granular. Quantum cosmology models propose that the universe tunneled into existence as a quantum event. Regardless of the model, one thing is clear: the universe began in a state of extremely high energy and extreme symmetry. All four fundamental forces were likely unified into one superforce. As the universe expanded, it cooled. Cooling caused symmetry breaking, a key concept in both physics and cosmology. Symmetry breaking happens when a perfectly symmetrical system chooses a configuration that is less symmetrical. Example, simple analogy: imagine a perfectly round ball balanced at the top of a hill. The ball could roll down in any direction, but once it starts falling, it picks one direction, breaking symmetry. In the early universe, symmetry breaking caused forces to split apart. Gravity separates first at approximately 10 seconds. Gravitational force freezes out. Grand unified theories, gut era strong, weak, and electromagnetic forces are still fused. Electroweak set approximately 10 seconds. The weak force and electromagnetism separate. This is when the Higgs field activates, when the universe cooled enough. The Higgs field acquired a non-zero value. Particles interacting with it gained mass. Particles that didn't interact remained massless like photons. This single moment explains why matter has massed at all. Around 10 seconds, a mysterious field, the inflattened field, triggered a dramatic Exponential expansion of space. Inflation expanded the universe by a factor of 10 in an instant. To visualize this, a region smaller than a proton expanded to something the size of a grapefruit in a fraction of a second. Why inflation matters. It explains why the universe is nearly flat. It explains why regions far apart have the same temperature. It stretched tiny quantum fluctuations into macroscopic patterns, the seeds of galaxies. Those fluctuations are visible today as tiny irregularities. In the cosmic microwave background, inflation stopped when the inflatoned field decayed, dumping tremendous amounts of energy into space. This energy reheated the universe to near Big Bang temperatures. This leads to, when inflation ended, the universe was filled with a hot plasma of quarks quants. Quarks quants procrontizer synonis. Over 1 trillion Kelvin quarks could not form particles yet, because the universe was too energetic. They existed freely in a soup, called the quark-gluon plasma. At around 10 seconds, the universe cooled enough for quarks to bind. Quarks plus gluons gives protons and neutrons, now matter as we know it could exist. Between 1 and 3 minutes after the beginning, protons plus neutrons fused to form hydrogen nucleosynthesis, fused into helium and a tiny amount of lithium. The universe was briefly one giant nuclear reactor. Important result. The ratios of hydrogen and helium produced match observations today. This is one of the strongest confirmations of the Big Bang. For hundreds of thousands of years, the universe was opaque, extremely hot, full of ionized plasma. Photons could not travel freely. They were constantly scattering at 380,000 years. Electrons bonded with nuclei atoms formed. The universe became transparent light. From that moment still exists. The cosmic microwave background cooled to 2.7 K. This is the universe's earliest photograph. Its temperature fluctuations match predictions from inflation almost perfectly. With the universe transparent, gravity could pull matter into clumps gas. Clouds collapsed for first stars formed between 100 to 200 million years after the beginning. These first stars' population, 3 stars, were enormous, hot, and short-lived. They produced the first heavy elements through nuclear fusion and supernova explosions. Over time, galaxies formed, galaxy clusters formed, and died planets formed, and eventually, life, from quantum fluctuations smaller than atoms, to galaxies larger than anything we can imagine. The universe evolved according to precise physical laws, and those laws tell us a profound truth. Everything, you, me, every star, every atom, originated in the physics of the early universe. You are literally the universe become conscious of itself.